Hello students, Assalamu alaikum. My name is Adil Abbas and in this lecture we are going to discuss about ionic radius trends in the periodic table. In the last lecture we discussed about the atomic radii, but in this lecture we are going to discuss about the ionic radii of the elements in the periodic table. So let us start by the definition. The distance from the center of charged atom to the periphery of the active sphere is called ionic radius. Remember, when we will talk about the ionic radius, we will consider the atom to be spherical in nature. So according to the definition, the distance between the center of charged atom to the periphery of the active sphere is called ionic radius. Just suppose this is an atom, and after losing one electron it became a ion, either positive or negative. So this is the center. Okay, this is the center of the atom, and this is the boundary, the periphery. So if we consider this one to be the boundary or periphery of the active sphere, this distance is called ionic radius, because we are talking about the ions. Okay, ionic radius of positive ions. First of all, we see that how an positive ion is formed. For example, there is an atom, sodium, okay. So we remove one electron from this. So it will become sodium ion, cation, because removal of electron from a neutral atom causes the formation of a cation. Cation means which develops positive charge on it. So when electrons are removed from the atom, then positive charged ions are produced, and the radii of the positively charged ions are smaller than the neutral atom. In this picture, we can see that this is the neutral atom of lithium, which is having a radius of 152 picometers. But after the removal of one electron, its radius is decreased to 16 picometer. So there are some reasons. For example, when we talk about this is the lithium atom. Okay, there are two electrons and one electron in 1s2. Okay, so when this electron is removed, only this shell is present. This is left only. So we see the electron is removed, the nuclear charge is increased. When nuclear charge of an atom is increased, it will attract these two electrons with more force. Okay, when it will attract the remaining electron with more force, the radius will be decreased. So this is why that the radii of the positively charged ions are smaller than the neutral ones. Even there are some more examples in case of beryllium, in case of sodium, in case of magnesium. Okay, okay. One thing more, magnesium is a member of a second group. Okay, we're going to remove all these things. Okay, magnesium, when one electron is removed, it causes Mg plus. When further we remove one more electron, it is called divalent cations. So the radius of divalent cation will be smaller than the monovalent cation. For example, this is the neutral atom. This will be the magnesium atom when one electron is removed, and this will be the divalent magnesium atom, because two electrons have been removed. So when the two electrons will be removed, the nuclear charge will further increase, and it will again attract the remaining electron with more force. That's why we say that divalent and trivalent species like aluminium. Okay, this is a trivalent species. There it means that 3 electrons can be removed from the aluminum atom. So this is all about the cations, ionic radius of cation. Let us have a look at the ionic radii of different elements like lithium, then sodium, rubidium, cesium. This is the second group. We can observe that the ionic radius is increasing down the groups because these two are groups of periodic table. Okay, so down the group ionic radius is increase. Okay, ionic radius of negative ion when an electron is added to a neutral atom, then it forms anions. So addition of one electron causes the formation of anion. So when electron is provided to an atom, negatively charged ion is produced, which is bigger than the neutral atom. For example, this is fluorine atom, and we add one more electron into fluorine. So this will form the anion. So this will be bigger in size as in case of this will be bigger in case as compared to its neutral atom. As you can see that this is the neutral atom of fluorine atom with 54 picometer size, and this is the fluorine ion, anion, when after one electron is added into fluorine atom. So you can see that the electron ionic radius of anion is increased. Similarly, chlorine, a neutral atom having ionic radius of 99 picometer, and then chloride ion, it is increased almost double of the neutral ionic radius, 181 picometer. So this is the reason that when electron is added, then one or more new shells are created, but the positive charge remains the same. So repulsion between the electrons is increased, and this is the reason that the size of anion is greater than the neutral atom. So here we can see that an ionic radius of anions is increasing down the group as well. Fluorine 136, chlorine 181, bromine 195, and iodine 216. We can see that ionic radii of anions also increase down the group, as in case of cations. So one thing is clear that in both cases, in groups, both cation and anions, their atomic radii increases down the group. Ionic radius trend in the periodic table, the same thing we discussed. The ionic radius, ionic radius varies systematically in groups and period. In case of period, when we move from left to right up in a period, ionic radii of positive ions go on decreasing. When we move from left to right in a period, okay, what happens that size of ionic radii of cations is decreased because we see that nuclear charge is increasing, and this is attracting the electrons with more force. That's why ionic radius of cations decreases from left to right in a period. But in case of ionic radii, the negatively charged ions go on increasing because repulsion of electron, addition of new shells, these two factors causes the ionic radii of an anion to increase from left to right in a period. Similarly, ionic radius trends in a group. Ionic sizes of positively charged cations go in increasing because when we move down a group, in a group of periodic table, we see that the atomic number is increasing, which means electrons are increasing. So when atomic size increases, so definitely the outermost electron will also increase in number, and the force of repulsion, attraction between nucleus and the remaining electrons, outermost electron, will be decreased. So that is the reason that ionic sizes of cations increases from top to bottom in a group of periodic table. Similarly, ionic radii of anions also increases from top to bottom due to irregular addition of electron, because we see that down the group the number of electrons are increased. So when number of electrons are increased, then there develops a screening effect. There are some more addition of new shells. So this is the reason that the force of nucleus and remaining valence electrons is decreased. So this is the reason that in group for both cations and anions, ionic radii increases. This is the today's lecture. Hope you learn something from it. For such more videos, you are requested to subscribe this channel.